Alright, so last section in chapter 12, and sorry this is so late. I got sick this weekend and talking wasn't a good thing, and so I'm late on this one, but let's get it done and then we'll be done with chapter 12. It is catalysts. I know that it's Amelia's favorite thing in the entire world, and hopefully we can clarify it a little bit. But the difficult thing about a catalyst is it can be literally anything. So I can't say, well, this is a catalyst and this is not a catalyst, because in one case it might be a catalyst and in another case it's not a catalyst. But what we're looking at with a catalyst is anything that speeds up a reaction, and Rxn is reaction, by lowering the activation energy remember, EA is activation energy, while not being consumed. Okay, so if I put something into a reaction and it itself is not part of the reaction, but it does speed the reaction up, it is a catalyst. So, yeah, clear as mud, right? An example of this is if you've ever seen it, Coke and Mentos. All right, in the Coke we have CO2, which is added to the water, and which makes carbonic acid. That's why your soda, your Coke is carbonated, right? This is the carbonation right here, right? When you put a Mentos, and you only need one, into the Coke, it reverses this reaction at an explosive rate. Okay, it changes all of this back into the CO2, and that CO2 comes out of the Coke very, very, very quickly, explosively. If you've never seen that, look it up on YouTube. It's really, really fun. We probably won't be doing it because it's really cold outside and I don't want to go outside. But maybe after the test we can go outside and have a day with Coke and Mentos. So if you guys remember to remind me. Okay. This would be known as a heterogeneous catalyst. All right, because they are not the same phase. All right, the Mentos is a solid. The Coke is a liquid. Okay, so they are different, hence hetero. Okay, boy, girl, right? Different. If you have a heterogeneous catalyst, it is what it does is it provides a surface for the molecules to bond to and work on. Because it never actually goes in, it is not absorbed, which is the word that we are used to using in our, it is adsorbed. Okay, adsorbed means it binds to the surface only, it doesn't go in. Okay, so with heterogeneous catalysts, it is adsorbed to the surface. It gives it the orientation, everything set up so that when the other molecule, say this is my other molecule, I don't know, something like that, when it comes, it's set up to react now. The other type of catalyst is a homogeneous. And that's when they are the same phase and soluble. Together. The book gives a whole bunch of different examples of atmospheric. So make sure you read over it, talking about the ozone and good things, bad things for the ozone, when we make it, when we don't, talking about acid rain, lots of examples, lots of talking. But basically what we're looking at with a catalyst is, remember we had this chart where this is my change in energy and this is my change in time, and I have my energy levels, and then it spikes and then it goes here, and we said that this was my activation energy, right? Right in there, that hill that I had to get over to make the reaction work. What a catalyst does is it changes where that hill is. So it's only to here now instead of to where it was before. It does not change the product. Or the amount of product. It just makes it easier. Well, let's go to the next page. It does make it easier to make the product. And by easier, I mean requires less energy. Alright, so hopefully that clears up catalysts a little bit. If not, then we can talk about it more in class on Wednesday.